Mill, mill, mill the aluminum. Cut, cut, cut into dust again. 0.1, 0.3, 1, 2 millimeter drill. I'm gonna cut anything that I want.
You might think the most exciting part of my week was watching 28 Years Later. It's finally in theaters, and you're right. It is the most important thing I did this week. But there is a close number 2, and that is milling. You know, I've 3D printed, I've laser engraved, but have I cut metal? No. I also went to see 28 Years Later. Did I mention this? It was a really good movie, and it was the perfect pastime for this project where I cut things out of metal. As we all know, big problems require big solutions. While I unbox this thing, I will talk about whatever me, the editor, says I should talk about. Now, I know how attention spans can be, so in this corner at any time, if you're uncomfortable, feel free to just watch me disassemble the thing. I know how it can be. Your eyes will drift there, just hear me talking, ignore it, and then, we'll come back to it. Okay, so the mission is simple. I need to design a coin, and it better be good, because I only got 1 block of aluminum. If I use this up, I am fucked. We need the correct contour of a coin, which isn't as simple as making a circle necessarily, but you know how like a quarter or like American coins kind of have this like perturbation, like this jagged line zigzag around it? I want that. Let's start off with a plane and apply geonodes, and instead of the input, I'm going to start off super weird with a star. What is he thinking? Why a star? If I increase the number of points, we get more points, and I can make this less extreme by changing the ratio between the inner and the outer radius. And I can then kind of flatten this sharp angle by using something called a fillet, which is almost like a bevel for curves. A fillet curve node. Set it to poly, which will let it not overshoot if we enable limit radius. Increase the number of divisions, and there you go. Maybe, do I want a count of 2? Count of 1? Yeah, I think I actually want a count of 1. Let's turn this into geometry by filling the curve. I need it to have some sense of thickness, which can be done by just extruding this mesh upward so it has some thickness. Now, it is important to know the thickness of the coin, at least our coin. I don't know what that's gonna be. Wait a second, I don't know what the thickness of the aluminum is. So I went on a quest to Home Depot to get some calipers. Listen, I need to pick up some material and more importantly calipers, because I don't know how big nothing is. If I overshoot by a few millimeters and say like the material is thicker than it is, what ends up happening? Oh, hello. What ends up happening is it engraves into the bed, which I don't want. So a trip to the Home Depot seems necessary. There was an expensive option, there was a cheap option. You know your boy's got money, so he chose the cheap option. For a caliper, what I settled on is this pocket one, because it's cheaper. I'm just gonna wedge something in here, figure out how many millimeters it is, put it in my pocket. Whee! And it turns out that when I measure this aluminum, it comes out to 5 millimeters flat, which is gonna be thick as fuck for our coin, but that's what we got until I get more material. I'm just gonna eyeball it. Let's set the offset to be, I don't know, that kind of feels coin-like. And then finally, I wanna take like a circle here and punch it inward so that the coin has a bit of a lip. We can do this by literally cutting out one piece from another. Specifically, I'm gonna use a cylinder, which you can think of as a circle with thickness, way higher resolution, decrease the depth, decrease the radius, and we can see what this looks like in the context of joining both of them. I'm going to increase this radius until it has roughly the lip that I want, and we now need to cut one from the other. If we look at this side view, it's going way too deep. It's actually cutting all the way through. I'm going to transform, say get out of the way, just move this up, and then instead of joining these together, I need to cut one from the other. That, by definition, is mesh boolean. We are going to take the original and cut away the cylinder using a difference, which looks something like that. It has a nice lip, but that's looking pretty good to me. And maybe on top of this normal fillet, I can fillet the fillet. Let's see what that looks like. Bring down the radius. Yeah, it's almost like we're doing 2 passes. Before and after, I think it adds quite a bit to this coin, especially when we see it up close. I need to put something on this coin. Is if I enable these overlays, we have this kind of 3D view gizmo. Some people use it, some people don't, but I really do like the way that it looks, and it's kind of a flat design to begin with. I'm gonna move this off to the side, mesh circle, that should be a higher resolution, and set the fill type to Ngon so that it is solid. I can then take a screenshot, there we go, and I can load that into the image editor so that we can always see it. So if we look at this up close, from Z to negative Z is 180 degrees, and it's split into 3 sections that I'm gonna assume are equal, which means each one has to be 60 degrees. 180 divided by 3 is 60.
2 + 2 is 4, -1, that's 3, quick maths.
This is actually good business for us. So I'm going to shift it over by, let's say, 5 units on the X. The number is completely arbitrary. And then by changing to the 3D cursor for our pivot point, I can rotate like this. I'm going to rotate by 90 degrees, duplicate, rotate by -60, duplicate, rotate by -60. And let's actually take part of this and extrude it downward. So maybe these 4 vertices that are symmetric about the Y-axis, E for extrude and then Y, all the way to the bottom here to create this kind of attacher. And to make sure that these are level, scale on the Y-axis by 0. Take it, duplicate, rotate by -60, rotate by -60. Just 1 second. I need to take a break because a side plot has developed. The CNC machine is actually quite quiet considering that it's cutting metal and all of this, but it does vibrate a little. And you know, who cares about that? Well, I'll tell you who cares. Ants. We didn't know, but apparently we have a ant infestation. The nest was actually semi near the mill, and the vibration had the ants coming out, kind of exploring what's going on. And over time, I realized this isn't 10 ants, this isn't 50 ants, but we're either talking hundreds or thousands, or I don't even know.
I think I found some ants getting it on.
Oh, really?
Come over here.
I went to war with the ants. The CNC mill had to wait. I actually used some of the acrylic to smush them.
You caught me in war. This is embarrassing. I respect all organisms except for ants. Oh, another. Wait, come get this ant. Do you see the ant? Got it.
Where?
Once you've done this for a few days, your senses get honed. I think we're good. Situation contained.
We just got this like food bait that is supposed to, I don't know, it tricks them. They take the food back to their nest. It's poisonous. And what we like about that is the ants die in their nest, which doesn't let them, you know, kind of die outside, and then they can explore and basically move their nest. That is what we want to avoid. So the vacuum wasn't only for kind of taking out wood chips and aluminum chips, I guess. It was for vacuuming ants. Back to whatever, I don't know where I edited this in, so whatever I was talking about. Next, I need kind of the conjugate. So we have the -Z, the -Y, the -X. Shift D to duplicate, rotate by 180. Get rid of these legs. I for inset. Before I now like take these and then kind of raise them upwards with an extrusion, I want to punch out the letters. Add a text object. That text should be the capital letter Z, which I can position roughly over here. Duplicate, edit mode, turn this into a capital Y, capital X. I think it should be capital, but not too capital. Corbel bold. I'm going to go to geometry. I'm going to go to extrude. Yeah, hold down Alt while you do this, otherwise it's only going to affect the active object. And I'm just going to make this super tall. We're then going to run the convert to mesh operation. All of these are meshes that I can Control J join together. Taking one of these circles again, move it upwards and scale it down. Take every object that isn't the letter, Control J to join them, edit, and then extrude on the Z axis. Mesh boolean. What are we differencing away? Well, we're going to difference away the text. That needs to be moved down, so it's actually cutting. Apply the modifier, destructive, get rid of the text. And then for the depth of these like negative values, I can inherit the depth of the cutout here. I'm going to again use these global coordinates. So you can see the average Z value is 0.10 whatever. Copy this. And then I'm going to select these. I'm going to extrude by what? By that 0.108 number, which I want to add a negative to. Put this like design within it. And there you go. I mean, that's a coin. Is it the most beautiful coin in the world? No. What I like is this n-gon in the middle that I can inset and do things to. So for example, I'm going to inset here, go to edges and Control B, extrude downwards, Control B to bevel, and just add some free, shaping to it. For this like geometry over here, I can also extrude it outwards, and I'm basically going to slice a line in the bottom. So there's a top and a bottom, and then extrude anything outwards that was below the slice line. I do not remember. Bisect? Yes, kind of direct it in this direction, making sure that it's kind of level with the surface. This is great because now in edit mode, I can select these faces that we just created, move these upwards just a little, Alt E to extrude, but not just normally. We want to extrude along normals. This will let us do it outwards. And maybe the missing component is coins always have text, right? Established in whatever date. We're just going to write some BS. So something like, in Suzanne we trust. I'm going to make sure that we're using the same font, that kind of bold font. Add that geometry extrusion so it has some height. And now we just need to wrap it around the surface, the circle, somehow. You don't want to use this raw geometry. You can see it has n-gons and it's messy. I found the best way to do this is with a remeshing. Literally take the text, add a remesh, which is going to be super low resolution. So keep dividing the voxel size until it's like sufficiently small. You then center it. Otherwise this deformation is not going to work. And then finally, I need a guiding curve, which can literally be a Bezier circle. That is roughly the correct size. And if we zoom in here, you can see it's super low resolution. So make sure in the curve, you add resolution here. We now want to add a curve. Yeah, deform along curve for the Bezier circle. And there we go. Take this like geometry and scale it downwards. And then we can take the circle and also use this to kind of say where it's supposed to be and even do a rotation by 180 degrees. When was Blender founded? No. When was Blender 3D founded? 2nd of January, 1994. 1994. It should use the same font as everything else, and we're just gonna repeat this process. Okay, let's wrap this up. Take the object, add a mesh boolean. What do I want to cut out? The first text. So now we can do another mesh boolean, so one after another, set it to fast, set it to the other text, select everything, Control A, where is it? Visual geometry to mesh. When we select that, it's basically gonna solidify all of this so that there's no more modifiers. Take these, join them, and now we have a single coin object that has no bottom. Alt-click to select this loop over here, F to fill, and now it's a solid coin. We're good to go. I'm going to export STL, so this is going to be my coin. Click export, and you literally don't need to do anything else. You have your STL, and now we pop into the software. Now that we've modeled our coin, we're at the easy part, which is basically telling the machine what path should you cut along to make that model, and we're going to make that using Makera Cam. This is a 3-axis project. We're not like rotating a cylinder. And here's kind of the quick breakdown. Middle mouse click to pan, shift middle mouse to orbit. You can also use this tool right here, which is mainly what I'm going to use. And to import our 3D model, you literally just import your STL. First thing always is let's define our material. So aluminum should be a preset. I don't really know a lot of these actual numbers, but I did measure, because we got those calipers, a 5mm height. And let's just call this 100 by 100 material. M to move, S to scale, R to rotate. So this should be 5mm thick since it should be using the whole coin. If you don't see any of this updating, by the way, go to rotate and just kind of like rotate and unrotate until, it updates. And this is now ridiculously huge. So I'm going to unlink, which will let me change these independently. And let's do an X and Y of 50mm. If I now look at this kind of front view, you can see it's not where it should be within the bounds. This is important because it either won't cut material or it will cut too deep. So to auto align, enable the bottom mode, which will move the pivot if I do a quick align stock right to where it needs to be. Normally, you do what's called a roughing pass where you get rid of a lot of material, then a detail pass where you go to the nitty gritty, and then a contour pass which will cut out the thing from the material. With this model, I'm going to right click, I'm going to go to tool path, a 3D path since we're going X, Y, and Z, and we're going to use something called a 3D relief. If I look at the side view here, you can see all those details don't really go all the way down to the bottom of the coin. So I'm going to set a max depth of like, I don't know, 4mm or something like that. We are going to pick a tool. These tools are going to be different depending on the process, such that it just gets rid of a lot of material. So I'm going to delete this and replace the tool. I'm going to use this one, which is a 2mm, accurate but not too accurate, perfect for getting rid of material. That is the 2x8 with the aluminum preset. Click choose. And now that we have our tool, we need to say, how do you use it? The main settings to care about after setting the tool number to 1 is the step over and the step down. Super simply, step over is this XY resolution. I'm going to do a 1/10 of a millimeter. And then for the step down, which is kind of the same thing, but it's the resolution going down, drilling down on the Z axis, we also want to be fairly precise with with 0.1. Finally, with the depth allowance saying how close can you get to the surface to begin with, let's also set this to 0.1 so it doesn't, mess up the detail pass. We need to say where we're going to cut, so it is going to be on the model. Parallel's fine, climb's fine, and in this case, outside boundaries fine. Only thing you might want to change is ramping, which will kind of smooth things out. It won't go directly down, but it will kind of come at an angle. 3 degrees, fine. Select your model, hit calculate. And just like that, you can see it calculated a path that I guess is fairly detailed, and you can see it doesn't go all the way down and cut it out of the material. This can be our rough pass. So here we have our models and everything to manage, and we can now again, I'm just going to hide this and select our coin. We're going to do another tool path, a 3D relief. This time we're going to get much more accurate. So I don't care about the max depth. And then for our tool, we want to make sure we replace this. So I'm going to add tool. I'm going to use like the most precise one I have, which again might be overkill. It goes down to 0.1 millimeter engraving. So in the engraving metal section, you're going to see this corresponding one. And then very importantly, make sure that this is tool number 2. Luckily, we don't need to think about step down because we're going all the way into the surface, which also means depth allowance should be set to 0. And then as for the resolution, 0.05 still like stupid precise, maybe even 0.03. We're again going to do the model boundary. We're going to set it to parallel, etc., etc. The only difference is this time we're going to cut on the boundary. So it should be exactly within the lines for maximum precision. Enable ramping, hit calculate. Now you can see here, this gets stupid detailed, like it goes within our letters, which is exactly what we want. Rename this to detail. And now the final thing is we need to cut this out of the actual stock that it's part of. Ideally, you have an SVG outline saying what is the boundary. We do not have that, but the software can calculate it for us. So I'm going to right click the model. We are going to trace a 3D contour. By default, you're going to see it's not perfect. Like it gets this outline, that's fine, but it doesn't get the details within. We can very quickly just highlight sections and hit delete. It really doesn't take too long, but we do want to make sure we have no points left so it doesn't like drill all the way down within our coin. We want to take this path. Well, it's not a path. We want to take this contour and turn it into a tool path. This one's 2-dimensional, just this top-down thing, and we're going to make a contour. I'm going to set a end depth saying go all the way through the material. So not just 5 millimeters, but like 5.1. And then for the tool, we're going to once again choose, I'm asking you to once again choose our 2x8 millimeters set to aluminum. This, remember, is tool number 1. It exactly corresponds with the very first thing we used. By the way, if I covered it, 5.1 on the end depth. Then for the step down, again, it doesn't have to be stupid accurate, but I think 0.1 should be fine. Outside the boundary is great, so it doesn't go into our coin. Ramping's great. And now the only thing we want to change is we're going to add something called tabs. When you cut out the contour, it's quite likely that at some point the coin's going to come loose and then the drill is going to go where it isn't supposed to. We want to make sure we don't cut everything, just leaving a bit of structure there. I'm going to add a custom tab. That's what it does. Pretty narrow tab at like 3 millimeters and at a thickness of like 0.5 millimeter. We don't want it to be too strong because otherwise we're not going to be able to take it out of the surface. Add, just click on different parts of this contour. Normally you kind of pin the 4 corners. You don't want to do too many of these. Click calculate. And then finally this, we're going to rename to our contour. That is literally all we need to do here. So when we're done, you just hit export. We say we want our roughing pass, our detail pass, and our contour pass, making sure that these are all correct settings. Hit export, and this is going to make G code. Click save, and we can actually close the software. So here you can see it made our coin, and what is it? It is 5 megabytes, which I think is perfectly fine. Now this is where the moment of truth is. So I'm going to go to my controller program, which is specific to this kind of machine, and we're going to send information. I've connected the machine with USB, so let's connect to USB. I think usually it's COM3. Okay, there we go. You want to see this blue idle. And now let's bring in the G code and hope for the best. So to do this, you want to upload a file, find the one you made. So that's coin.nc, which is 5 megabytes, hit upload and select. And do expect this to take a moment, longer than you think, which is why I would say not doing, like I had an 80 megabyte file before I figured out how to optimize. Let's just kind of wait for this. Okay, we're glitching. Okay, we're there. So here you can see all of the instructions. Before anything, I would highly recommend doing a home. What this means is it puts the thing where it's supposed to be. I'm not going to mess with any of these other settings. I'm just going to let the software take it away. So hit run, like start running G-code task. And this is where we check that everything is going to be correct. So we need to check that we're within the margin. We're going to want to auto Z probe so we know the height. We're definitely going to want to auto level because we only get one chance here. And because 5 is a lot, like these are 25 things, I'm just going to do a 3x3. So it's going to sample 9 points to make sure everything's level. And if not, it's going to count for that. Click OK and then hit run. And before I go, it's always going to make sure you're using the right tool. So it's going to be probe, then tool 1, then tool 2. Let's get it started.
That is not going anywhere.
Now, what you're watching me do here is the milling operation. I may look confident in what I'm doing, I'm not. But from what I understand, you start with this probing process where it probes the surface, and it basically tells the machine, here's the ground, here's how misaligned it is, and here's kind of like the margin where the workspace is. Once that is confirmed, we then do a quick tool change, because remember, we're doing the roughing pass first. One of the selling points of this mill is that apparently a lot of them aren't easy to change tools. This one's super easy to change tools. It actually does it automatically if you want, but I'm going to do the manual approach. It's then going to do this roughing pass following our G code. Just beautiful. And then when it's time for the detail pass, what do? You swap it out again with the detail tool. Now, I may have picked the wrong settings. I didn't actually record this in order. I did a whole bunch of attempts and then told you the correct settings, but it does take a moment to get used to milling. Nothing as bad as 3D printing. Nothing can ever come as close to the horror of like trying to get out stuck filament and stuff like that. But it was good because I tried to cut out different materials like aluminum. I did some like wood, some acrylic. Sometimes I cut too deep into the board, but you know, what are you gonna do? And yeah, this video is a plug for Makera Carvera CNC Air. That's a lot of words. They sent me this thing in exchange for me making a project, and when I received that email, I could not be happier. I was jumping up and down, being like, finally, my lifetime dream of having a CNC mill. I run to my parents, I tell them I've made it. Anyways, I wanted to make a coin. Why not print money is kind of what I figured. Now, as far as mills go, I know there's like the industrial ones. They're stupid expensive. I'm not building like a weapon or something like that. This is it's sold as a desktop CNC mill, and I'm surprised. The box was heavy, don't get me wrong, but I was surprised at the footprint of this thing, and more so how quiet it was. Kind of the main things I think they like to talk about is quick change tool. We talked about that. Sub-millimeter precision. Has a cool name, has a cool look, and it has a hood so that the chips don't fly everywhere. And I actually hooked up an air assist to blow air away from the drill bit, which I think creates cleaner lines. That's it for me. Goodbye.